Hello developers, let's start developing. Welcome to the 2024 Advent of Code. So today we're gonna take task 1. I haven't seen it, this is my first time that I've seen it, so let's take a look at it. The chief historian is always present. Yeah, 50 stars, we know that. Each puzzle 1 star, we know that as well. The list of location to check is currently empty. Oh, we have a location ID. Two groups is certain. The complete list of locations. Holding the two lists side by side, your puzzle input lists aren't very similar. So we have these things. So maybe the lists are just off. Pair up the number and ensure how far apart. Pair up the smallest number in the left list with the smallest number in the right list. Then the second. Uh-huh. So we'll need to pair this one, I guess, with this 3, and that means that the difference is 2. Second smallest number, the distance is 3, distance is 0. Okay, so this is our example input. Let's put that here. And now, so basically the task is quite easy. We just need to find the minimum in the left list, the minimum, the sort, the left and the right list, and then see that. But the processing will be quite tricky. So we're gonna need to read all the input lines, and what will our output be? Our input will actually be a series of actually this. We will have a number array. Oh, my typing skills seem to have deteriorated. Number array. So we will have exactly a tuple of 2 number arrays, and we need to return a number. Okay. So how do we process that? Yeah, let's just use some TypeScript and declare this as a type. This is a number array tuple pair. So we can just use this everywhere, which means that our input will actually take this. Now we have the problem of actually creating that. So process input should return a number array pair. So which means that we're gonna need to read all the line. Let's say we have first, which is a number array and it's empty, and then we have the second as well, and then we're gonna need to loop through the lines. For of line of lines, it thinks that we have that, but we don't have that. We have spaces. It makes sense to here we have only 2 spaces, but in the big input we also have 3 spaces here, so that might be an issue. Yeah, we have 3 spaces here as well. So yeah, we're gonna hard code that. Split on 2 spaces. So in the first, push the number from the first left side, on the second, push the number on the second side, and then return an array of the first and the second. A pair, not an array. So now with, oh. And when we're working with tuples, sometimes you need to explain to TypeScript that you're actually gonna work with tuples. So part 2 we don't have that, but we will just comment it out since we don't need it. Show input also takes the number array pair, and test should also take a number array pair. so that we can do that. So now let's just console log the input. Let's see if we're reading this correctly. Always test, always see what is actually happening. So we have three arrays, and the first array is 3, 4, 2, 1, 3, 3, and we want it to be 3, 4, 2, 1, 3, 3, and the second one is 4, 3, 5, 3, 9, 3. Now there is a trick. We will sort them initially, but there is a bit of trick to sorting arrays of number in JavaScript. It will work, but if you have an array something like 1, 2, 5, 4, 10, JavaScript will initially sort it 1, 10, 2, 3, 5. It will sort the numbers lexically, which is something that you never want. So I think I have enough. My JavaScript is recent enough, so this will work. Let's just see if it actually does. There is a cool toSorted method, because sort actually works in line, and I don't want to do that because that will destroy my input. So I will try actually to say input of 0 toSorted. So this will be the first array, and let's just console log it. To see if this actually works. 1, 2, 3, 3, 3, 4. Actually, I will provide a sort, because if I add, let's say, 20 in the input here, it got sorted between the 1 and the 3 because it starts with a 2. That is not something that we want. What we actually want, we're gonna say the first, the second one, and sort on their numeric difference because they are numbers. So we want to have 1, 3, 3, 3 with the 20 at the end. I will return the previous input. So now we have the first F sort. Of course, we're gonna need to have the second sort. And we know that they have the same number of elements, so I will just loop them to a for loop. Yes, something like this. So we're starting from index. I don't like I as a loop parameter. I prefer index. We're going to increase it by 1, and then we have F, we have S, which are the elements. That is not something that we need, but we want to have their difference. So we don't have a negative. Let's see if we need to take care if the right number is smaller than the left number, then the difference might be negative. It's not covered in the specification, but I will assume it. So I will just say math.abs of the first minus the second one, and that is the distance. And I will just define total distance to be 0, and now of course we're gonna increase the total distance by the distance and just return the total distance. Let's see if this makes sense. We should get 11. So let's have the big input now. And it says that the total distance is this number. I might have read the absolute requirement a bit wrong, so I'm not quite sure whether this will be the correct input or not, value or not. But it is. So I guess that was a trick that I got on hold of it. Let's see what part 2 is. The two lists are indeed very different, or are they? Okay, we have two groups of historians, of course they won't agree on anything. A lot of locations appear in both lists. Aren't location misinterpreted handwriting? Ooh. Similarity score. Each number in the left list after multiplying it by the number of times that number appears in the right list. Ah? Okay, so we have 3. And it's 3 times in the right list, 4 one time in the right list, 2 doesn't appear, 1 fifth number. Okay. So we need to calculate some weird metric. For that, we need to do what? We need to go through the left list. Actually, I'm gonna say first is input of 0. Do I have a histogram function somewhere? Because we're gonna need to have a histogram functions. This will be a function that will take an array of numbers and basically return a map of how many times each number occurs. This is quite well known, so I will let Copilot write it for me. So we're going to create a new map. We're processing the input. We're seeing if we have that element. If we have that element, then we get the count, otherwise the count is 0. First time we counter that. And we're setting the occurrences to be occurrences plus 1. We're returning the histogram. So let's go back to the small input. So now we're gonna have fhist, which will be the histogram of the first one, the histogram of the second one. We're gonna console log them, and the second one, and return -1, which is definitely the wrong value, but let's see. So we have the first one has 3 3s, 1 4, 1 2, 1 1. Seems correct. And the second one has 1 4, 3 3s, 1 5, 1 9. Seems about right. So now what we will do, we need to go through we're not gonna go through the first array, because you can see that we have 3 3s and each time their similarity score is 9. So we can just say the similarity score should be multiplied by the number of occurrences. So we need to go through each of the elements of fhist. So now here the element is basically a pair of numbers when the first number is the actual element and the second number is the occurrences. So I will say this, I will deconstruct this to key and occurrences. Actually I will say occurrences is in the second list, and in the first one we will call it times. Yeah, let's write that. So we should get 3 3 4 1, and I shouldn't have removed the return 0 or -1 because that caused an error. 3 3, yep, that is correct. And of course we're gonna need to define a similarity. which will be 0. So now the occurrences will be how many times the second histogram has that key. If it doesn't have it, then it's 0. So we will need to add to the similarity, not this thing, but we will need to multiply it. So we're multiplying how many times we have, what is the value of the key, how many occurrences does it have. Those are 3 things. So we have the key times occurrences. And that is the score of that key. And then I will add the score to the similarity. I like it this way because it's better for debugging. If I make some errors, I can then write out the individual scores and see how it is, because I'm not going to make a mistake in this part. Not excluded, but rarely, I will say. So let's see if we get the similarity score. That should be 31. Let's run the code, and it says that the similarity score is 31, which means now we can go to the big input. Let's see. And it says the similarity score is this huge number. Let's try it. Seems that it's correct, and I have 2 gold stars right now on my advent calendar. So it was a small and fun task, and the biggest problem was actually reading the input, because we are reading the input line by line, but we need to separate those because the left part goes on one side and the right part goes to another side. So the processing the input was a bit tricky, and I expect that a lot of people had problems with that. Another issue, which is kind of JavaScript specific, is that when we needed to sort them, we needed to specify that we want to sort them as numbers. That's this part. Because when we want to sort them, we want to sort them as number according to their difference and not according to the lexical order, because 10 is not less than 2. It comes first in the dictionary, but that's not what we want. Another thing I suspect that might not have made a difference, actually let's try it. It's this number if we're using ABS. If we're not using ABS, let's see if that number changes. Yeah, it does. So this was a hole that we didn't fall into, because it's kind of implied that we need to add up all the distances, and the distance is always positive. But if we don't take that into account, that the second number can be smaller than the first number, and we just add up the differences, then we might get into a situation when we actually remove some items and calculate them correctly, because the distance is always positive. The difference can be positive and negative. So this was yet another trick that we didn't fall into. And the second one, as long as we thought of making this into a histogram and not doing multiple passes through multiple arrays, this was performant and easy to do, because the score is just the multiplying 3 numbers together. Anyway, it was a fun task. I'm glad I solved it on the first try, and keep developing.